Welcome back to the channel, and we're working through some harder GCSE questions, and I've chosen 5 to start with, and then we'll do another 5 and then another 5 after that, and slowly work our way through the harder questions. At this stage I will say, if there's anything you found that you really would like me to do, let me know and I'll sort of push that up the list a bit, but for now we're just looking at this one. This is from an IGCSE. IGCSE tends to do slightly harder vector questions than the normal GCSE, so if you can do this one, it means you can definitely do the harder GCSE ones. As ever, pause the video, have a go. This is difficult and I'll explain why once you've had a go, and I'll talk to you all soon. Okay, so hopefully you've all tried this question. As I say, it's much more difficult. The reason it's difficult is because it's asking you to do something but not really telling you how to do it. It's not giving you any help as to what to do. The other thing that makes it hard is the way that I'm going to do it is by far not the only way of doing it. There are many different routes to do, and the process is, and you can see here, I want to work out the O to P vector, and there's lots of ways I can go. I can go across here and down here and back here, and I can go up here and down here, or I can go down there and across there. There's lots of routes to doing this question. The process that I'm going to do is I'm going to work out 2 ways of getting from M to A. So in other words, I'm going to go from here to A, and then I'm also going to go from here to P, and then I'm going to compare those 2 things and say those 2 things are equal. And if I do that by using the fact that I've got O to P within my calculations, that will then give me the value of O to P that I need. Let's do it and it'll make a bit more sense. Now, my process is whenever I read through these questions, almost always all the question information is relevant in some way. So case in point, so it says O to A is A to A. So the temptation is just to write A to A here. And actually in this case, that's fine. There's nothing else it tells me about O to A. How with O to B, it says O to B is 6B, but then here it says O to M, M to B is 1 to 2. In other words, this is 1/3 of O to B, and this is 2/3 of O to B. So if the whole of O to B is 6B, well, 1/3 of 6 is 2, so it means that this is going to be 2B. And this here is also going to be 2B times 2, which is the other B, or 2B plus 4B is 6B. So that's given me something to start with. Then, like I say, I need to think about the way I'm going to do this, and I'm choosing to concentrate on the line M to A, of which I know P is on that line somewhere. So I need to set up vectors for those variables there. Now, unfortunately, I'm going to be jumping up and down a bit, so I apologise now, but it's the only way I can think of doing this. So the first thing I need to work out is I need to work out what the vector A to B is. And the way I'm going to do that is I'm going to go from A to O and then O to B. So therefore that's going to be minus A to A plus 6B. Then I'm going to work out what A to N is. Now I jumped this quickly in the question because it didn't actually come up when I was putting my things down. So it says here that N is the midpoint of A to B. So therefore A to N is going to be minus 4A plus 3B. So far so good. Now this is where we have to start being inventive as to how we do this question. So ultimately, remember again, always keep your eyes on what you're trying to do. I'm trying to work out the vector that gets me from O to P. That's clearly some proportion of O to N. So I'm going to need O to N at some stage. So therefore, the way I'm going to work out O to N is I'm going to work out O to N by going from O to A, and then I'm going to add on A to N. So in other words, that's going to be 8A, which I got from the question, plus the thing I've just worked out, which is minus 4A plus 3B. And if I combine all these things carefully, that tells me that O to N is going to be equal to 4A plus 3B. Okay, so far I haven't really done anything of note beyond just combining vectors. This is where the part comes in that I know when I teach it that pupils tend not to like. I'm going to say, I'm just going to create this as me saying it's true. I'm going to say that O to P is lambda lots of O to N, which means that O to P must be 4 lambda lots of A plus 3 lambda lots of B. Now, why lambda? Lambda just comes from A-level maths when we teach that, and it's what we tend to use when we do degree math and similar. To be honest, you can use P, Q, R, S, any letter you want, but lambda just happens to be the one that we use. And when I teach it, we tend to call these the lambda questions just for that reason. So I've got something that tells what O to P is, but clearly that's not the answer, because ultimately I need to find out what lambda is. So this is where I go to my technique. Remember what I said again. I'm going to work out what M to P and M to A is, because I know those two things lie on the same line, which means I must be able to say something about the coefficients. So let's write that out, and it'll make a bit more sense once I've written it out. So M to P, again, let's go up, and apologies because I'm going up and down a lot. M to P is going to be M to O plus O to P. Okay, so that's going to be M to O plus O to P. I've got M to O, that's the opposite way of O to M, so that's going to be minus 2B, plus O to P is the thing I wrote above, which is going to be 4 lambda A plus 3 lambda B. I'm going to combine the coefficients here, so all the A's go together, so 4 lambda A, and all the B's go together, which is going to give me 3 lambda minus 2 lots of B. Now again, I still don't know what lambda is, but I have an equation for MP. How is that helpful? Well, the reason that helps is if I also work out M to A, and M to A means I'm going to go the opposite way from O to M, so I'm going to do that back to front, so again, minus 2B, and then I'm going to go all the way along O to A, and that's going to be A to A, and so therefore I've worked out M to A. And just so I'm consistent, I'm going to write that underneath here as 8A minus 2B. Okay, now as an aside, different question, but just to show you why I'm doing what I'm doing. If I write down two completely made up vectors, so let's say 6C plus 7D, and then I write down 18C plus 21D. If I ask you, are those two vectors parallel, you would hopefully say yes. And the reason you would say yes is if I take this one here, the first one, and multiply it by 3, I get the second one. I can, in other words, say if I take the numbers before the C, the coefficients of C, and divide them out, and I take the coefficients of the D's and divide them out, I get the same number, which is 3. So vectors are parallel if they are multiples of each other, and that means every letter or vector has the same multiple between them. Now, because MA and MP lie on the same line, and again, apologies, I'm going up and down a little bit here, because MA and MP lie on the same line, they must be parallel because they're going in the same direction, which means it must be the case that the A's, so 8, divided by the A's in MP for lambda, so let's highlight what I've done here, so that there divided by that there must be the same as the B's divided by the B's, where I'm doing it in the same order, or the same direction. So that's 2 divided by 3 lambda minus 2. Okay, and before I proceed, I obviously made an error, haven't I? So we need to be very careful when we're doing this, especially when we're trying to demonstrate these, because actually that's not a 2, that's a minus 2. So actually that minus 2 goes there. What do I do now? So the next step is I can cross multiply, a term I don't really like, but it sort of works well here to demonstrate it. So that's going to give me 24 lambda minus 16 is equal to minus 8 lambda. And if I add 8 lambda to both sides, that's going to give me 32 lambda is equal to, add 16 to both sides, 16, which means that lambda is going to be a half. Let's be clear about what that's saying. That is saying in my diagram right at the top that M to P is half of M to A. It doesn't look like it in the diagram, but that's what the vector math tells us, so therefore it's fine. Now we need to go back and make sure we've answered the question. The question says, using a vector method, find O to P. It doesn't say find lambda, it says find O to P. So I'm going to go back to my O to P, which is here. I'm just going to highlight it for you here. So there's my O to P. I'm going to put a half instead of the lambda. So therefore O to P equals 4 times a half, which is 2, equals 2A, plus 3 times a half, which is 3 over 2, times B. That is not an easy question. It's a very difficult question, but equally, if you can get your head around that question, you can do arguably some of the most difficult vector questions. Any comments, any questions, anything you're not sure about, put it in the comments. I will come back to you. I will let you know. Like I say, if you've done it, leave it a week, do it again. Just let it sink in as an idea. These questions are difficult, and I know from teaching it that a lot of students struggle with these questions, and that is fine. Just keep trying them again and again. They do. Another question tomorrow, so question 4 out of 5 of the current set that we're doing. So please do catch up with that one as well. Like and subscribe, it just means you keep up with everything that I load on the channel. Thanks all, bye.